Hello and welcome back to this AWS course. We're currently in section 4 and this is lesson 6. And here we're going to look at how a client can upload files to an S3 bucket via a serverless Lambda. This is probably best explained through a picture, so I've found one over here. If you Google serverless S3 presigned URLs and follow this link, you should get to this page here, and there's an excellent picture which shows you what's going on. So the client is going to make a request through to a Lambda asking for a presigned URL. The Lambda is going to call getSignedUrl, which is a function built into the AWS SDK. And that function will then take over and it will create a brand new file in an S3 bucket, and it will return back to the Lambda a URL, which is essentially a reference to that file. And the Lambda will then return that back to the client, and the Lambda at that point will then be free to exit. And then as a completely separate operation, the client will use that URL to essentially copy their file into the bucket. So note that when the original request was made, this was a completely dataless request. There was no file name, no file size, and certainly no file content. It was just a request for a URL, and then the entire transfer happened offline after the Lambda had exited. And this means that if the client is on the end of a very slow network connection or has a really huge file, they can take their time over doing this. This could conceivably take hours, whereas the Lambda operation of getting the signed URL will typically take less than a second, and that will fit in with the architecture of serverless applications. So with that, if you'd like to follow along, just visit richardbraycourses.co.uk and scroll to section 4 of this course, where you'll find a link to the repo. Every section has its own repo, and within the repo there's a folder for each lesson. Lesson 5 didn't have any coding, so we're going to pick up where we left off at the end of lesson 4, so just copy this code here. Okay, so with that, this is that code, and we're going to start by editing the API server. So here it is over here, and as you can see, at the moment we've just got this single health endpoint. So I'm going to add another endpoint to allow the user to request this pre-signed URL. So let me just copy that in. And it's making these calls, so I'll just add the imports in as well. Okay, and now it's complaining that these two libraries don't exist, so we'll add those into our package.json over here, with just these couple of lines here. And if I now run pnpm install in a terminal, those libraries should be loaded, and these should go away. Okay, so now let's look at the code. As you can see, the first thing to notice is this is a post endpoint. So if you're not familiar with the difference between get and post, let me just show you. If you Google MDN HTTP request methods, there's a little bit of documentation here, and there are essentially different calls that can be made from the client. Get, as it says, gets data. Post is essentially an insert, and put is an update. So this is going to be an insert of a brand new URL. So this is the express function call to handle this endpoint. So the first thing we do is we call the S3 client constructor, and this is essentially an SDK call that is going to inquire on who's actually running this code. So this code may be running in a Lambda, or it may even be running locally, but it'll essentially find out who the AWS user is, and that will be returned in this S3 client object here, and that will allow other function calls to know what the correct permissions are. Now this call here is very interesting. It's assuming that their bucket exists. Now we haven't sort of spoken about this yet, but if we look at our CDK app for the API server, up until now we've created a Lambda function, we've created an API against it, but we didn't create a bucket. So we're going to have to come back and create a bucket in this stack. But let's assume that's happened. The other thing this code is assuming is that the name of the bucket is available in the environment, And again, we can put some code into this when we create the Lambda. We can put some code down here which tells the Lambda what the bucket name is. So again, we'll come back and do that shortly. But assuming there is a permissioned client and there is a bucket name, we can go ahead and make this call, which is the essence of what we're doing. And here we're calling signedUrl just like we saw earlier on. We pass in the client details so it knows what the correct permissions are, and then we tell it what we want to do, which is in this bucket we want to create a brand new file, and we give it what's called a key, which is essentially the path and the file name all joined together in one string. We're not going to bother with a path, we're just going to go with a simple file name that is a randomly generated number, and we're advising it that the content of this file is going to be an image. And lastly, we specify how long the URL that's generated is going to last until it expires. So here we've got 900 seconds, which is 15 minutes. So that's how long the user of this URL has got to complete their file transfer. And then we return this data back to the client. And as far as the API server is concerned, that's all that we need to do. But as I mentioned earlier, we also need to update our stack. So let's just go ahead and do that. So I'll add in the bucket creation code here. Okay, so let's have a look at this. These two items here are essentially saying if we delete the stack, we will also delete this bucket. That's purely because we're in a development environment. You wouldn't want these in production, or when you deleted your stack, you would destroy the entire bucket and all its content. So there isn't general public access to the bucket, only through the pre-signed URLs. And here we've got some CORS permissions, and we're allowing puts. This will be sufficient for the user to update the file via the pre-signed URL. So having created the bucket, we need to pass its name into the Lambda as an environment variable, and that's easy enough. We can do it with 3 lines of code, so I'll just paste those in here. And as you can see, we're creating an environment variable called images bucket name. If you remember, that's this name over here. And we're assigning to it the bucket name that was allocated up here. So we have used an internal name of photos bucket. The CDK will actually add some numbers to this to make sure it's a completely unique bucket name in the AWS universe. So the last thing we need to do is allow the actual Lambda to go ahead and do stuff in the bucket. And to do that, we add some permissions to the bucket itself. So we say to the bucket, please allow this Lambda to read, put and delete. A couple of these we'll be using later on, so might as well add them in here. And with that, that's all the changes we need to make. We've updated our stack and we've updated our API server, which is called by index.ts down here. So the last thing we need to do is just deploy, and in order to do that, let me just show you our root package.json. We'll just call this CDK deploy API server. So we'll use the alias prun CDK :deploy :API. Now, I had actually done a dummy run of this already, so it was very fast, but you can see that this is all worked successfully. So that's complete. We've updated our API server to provide pre-signed URLs, and we'll set about using them in the next lesson.